So basically this is a 3-phase Bldc drive. In this we have the option for applying AC input as well as DC input directly. So we can apply DC input for this particular motor. We can apply only 24 volt. For any other motor in the rate of 100 volt, 200 volt, you can apply. So at that time we can use AC also. So internally this board has a rectifier. This is a rectifier, that grey one. Internally that grey one is the rectifier. So the rectifier rectifies the DC and the capacitor will make the DC. If it is the high voltage DC source is not available, you can use an auto transformer and adjust the DC AC, you will get the DC here. So this rail, this is the rail, DC rail. So here we will get the DC from the capacitor. Okay. Then this is the output of the IGBT. Here IGBT has 3 connections. One is positive rail, negative rail. Then the next one is a central point. It is like it is a half bridge. The positive leg, negative leg, and a center point. Center point is this inverter RYB like that, or GYB like that. So here, for working this IGBT, we need this driver card. This is a driver card. So first IGBT, first driver card. Second IGBT, second like third 3 IGBT Skyper. That is Skyper 32R board is used. But the problem is that the Skyper 32R needs 15 volt pulse. So the controller only gets 3.3 volt. If it is DSP also, it only gets 3.3 volt. So in order to amplify that, I will show that. You can see that you can take like this. Easily, but remember one thing, this port is there. So it goes careful. Okay. So that we can place this.
Yes.
Okay. You can see that we can remove this one. Already this port is now removed. How can insert? I will show you. You can see this is the controller. This is a FPGA controller. Here, what are the input? I will explain. Here, okay. From the motor, there will be a position sensing. This is Hall sensor. So this Hall sensor we are given here, but we need to given to the controller because the controller is 3.3 volt. So for there is a landing board here. In the landing board there, but the actual motor Hall sensor voltage is 5 volt. So we have to pull up that voltage. So from the controller only we have 3.3 volt. For processing the data to controller, we need to pull down to 3.3 volt. So here that board has 5 volt and ground. So this board is directly given to that 5 volt and ground here. You can see that this wire is there, 5 volt and ground is there. Okay. From that board there is one. You can see that resistors. So these resistors will make it to 3.3 volt. And from that it will come to here. You can see that this wire. These 3 wires are 3 Hall sensor, and it is given to this port. You can see that this port is 3.3 volt. Okay. And this one is the power supply for this board. This is 3.3 volt and ground. Okay. Then if we want the input is given. That is, one input is the Hall sensor. Another one is the throttle. For a vehicle point of view, this is a throttle. So we need to apply throttle here. So throttle that here. One option is there, that this potentiometer can be connected here. So second input is a port. Here also this controller doesn't have ADC. Port is analog. The controller is digital. So that IC is analog digital conversion IC. This one, this IC. So that convert that analog value to digital, and that is given back to here this wire, I think this port, that is P2, the header is there.
Okay.
P2 header is for ADC.
Oh.
That P1 header is for Hall sensor. Then the remaining part is the return. If it is ADC is there and Hall sensor is what is the output, we need to control the IGBTs. So we need 6 pulses. So this is the P6 header. The P6 header, there are 6 pulses. So actually the controller is supplying 3.3 volt only. We need to amplify to 15 volt for driving this driver. So we are placing, you can see that there is some ICs are there. This is a TLP250 based gate driver. So this gate driver will amplify this 3.3 volt pulses to 15 volt.
Okay.
For that one there is a 15 volt regulator is there. So to power up that regulator, the transformer is there.
Oh.
So the transformer gives 15 volt AC. There is a power supply is here. That is that AC is rectified to DC and regulated here. Okay. This is a rectifier. This is a regulator. Okay. So this driver IC gets 15 volt. So when a 3.3 volt pulse come here, it will amplify to 15 volt. That is given to this. The grey wire is given to this Kuiper. Okay. So from that pulse is given to this Kuiper. So if somebody want to do this for future, then they need the 6 pulses. As the inverter pulse. So remove this one. You remember that P6 header. So P6 header, there will be like that. I will show you that. Header is like that. One is upper is there. One is lower is there. Which means there is A bar, B bar, C bar. Like that programming is done. So this wire should be like that: A, B, C, bottom A bar, B bar, C bar, like that. So we need to take this wire, and also this is a ground. So these wires should be given to the another controller. If they want throttle also, they can use this throttle, because this FPGA doesn't have a ADC, but DSP has ADC. So they can directly use throttle to that board also, because that board itself has ADC option. Then Hall sensor also, if they want to work in 3.3, they need to connect these 3 wires to the controller. If the controller has a common ground, then it will work no issue. So once again I will tell, this is the ADC, this is the Hall sensor, this is the pulse, this is the ground points, common ground points. And like this you can insert. So we designed everything, the acrylic everything we designed.
Okay.
So you can verify and switch on this one. Then the power supply will come.
Okay.
Then you can use this one also. Then only it will come. Then you can check whether this is coming or not.
Okay.
Then apply, switch on here. You can use this one. Voltage current 24 volt output. When this vibration also coming. So if it is placing a accelerometer over here, just place it using some double side sticker. That data also you can get. You can place
how to fix this accelerometer?
Using a double side sticker or something. This also 5 volt and ground is to be, that you can interface to Raspberry Pi or something.
Okay.
That you can use interface to Raspberry Pi.
How it will sense this?
It's like a accelerometer. The X-ray is a position. Vibration is there. Slight readings, slight variation is there.
Okay.
Okay.
Can you explain this?
You want to change another node? Just remove this one. You can place.
So based on the speed and the radial dimension of this thing, vary. Weight also, it's different weight is there.
Some student is doing in different hardware. They will design this 3D printer. Any other node they can design with more weight.
Okay.
They just give a prototype. Okay, and very like that. suppose speed is not varying means that wire is not connected.
Oh, okay.
So if the speed is not there, you can like that.
Okay.
If this LED is not blinking means the hole is not connected. So you
We
can
have to
easily
check.
trace that equation. So he mentioned that in some widener, this is gate pulse, this is ADC, this is gate pulse, this is hole. If it is some option is there, make a photo and like that, mark it like that.
Okay.
Make a photo and this is ADC, this is pulse, this is hole. We apply to 24 volt, 250 volt or 400 volt. This is the idea stack.
Okay. So the supply we are giving based on this motor's rating.
If this motor is not there, some other motor come. At that time also, this we need to give that Hall sensor from that motor.
Okay.
But at that time, if this sequence is not working, at that time this sequence is there, GYB is there. You interchange that combination. In some other combination, that company's motor will work.
Okay.
Already we tested it and finally is that values GYB order.
Okay.
Sometimes that order may vary. At that time, the code is same. At that time, you need to change this value internally.
Okay.
Otherwise, you need to replace here internally. Then only they will work. This is a universal type, but for different motor, we need to identify the whole question.
Okay.
Different make, they will different. This is the IGBT part.
Okay.
If it is 230 only, then that fan is connected to here. So if AC is applied, that fan also will work and cooling is. For low voltage, the cooling is not needed.
Okay. Oh, now the fan is not running.
Because we are connected DC only. It is connected AC only, that fan will work.
Okay.
For high voltage.
Here it is connected. Oh, that is AC
It is a
fan.
230 volt fan.
AC fan.
Yes.
Okay.
If 230 volt is there, it will work. So this stack can be worked with a 24 volt motor as well as 200 volt motor or 400 volt motor. No issue. This stack can work up to 1200 volt. So induction motor, Bldc motor, PMS motor, everything can be done. For induction, there is no need of this one. Already we have the controller. No need of positive sensing and everything. So at that time, remove these connections and every time we need these 6 pulses. That is given through that this amplification 15 volt is given through this wire. So at that time we need to remove these 6 wires. That is upper wire is like that A, B, C, lower wire is like A bar, B bar, C bar. So that we are given to any other controller for programming that one. So at that time only these 6 connections need to be removed. Okay.